Okay, let's wrap up neuroanatomy, the neuroanatomy module, by looking at the functions of the two hemispheres, the two cerebral hemispheres. So we're going to focus on just these two hemispheres, and what this is stylized to mean that this is the frontal lobe. Here is the parietal lobe. Back here is the occipital lobe, and out here, jutting out like a ram's horn, is the temporal lobe. And we know that each one of these areas has a function. So the motor cortex primary motor cortex sits in the frontal lobe. Primary somatosensory cortex sits in the parietal lobe. Back here in the occipital lobe is vision, primary visual cortex. And in the temporal lobe, there's an area which is primary auditory cortex. And so let's say that there was a massive loss of a hemisphere. Let's say that this is the right hemisphere. Well, we would be unable to get somatosensory information from the left side of the body, and in fact, the left side of the face. And we would be unable to move the left side of the body and face. We would also lose the visual world that is on the other side of the world. So we would lose the left half of the visual world. Now, that doesn't mean that we lose the left eye. It doesn't mean that we lose the right eye. It means that we lose the left half of the world. We would be seeing, in this case, we would see, if we're looking here, we would only see information over here. This would be blank. Okay, so that's an easy way to think about it, and just to put a little bit of placement on this, let's look at where these various places are. This is the primary visual cortex. So this is the right hemisphere. It's going to carry information about the left side of the visual world. Over here is the primary auditory cortex. This is the primary motor strip, and this right behind it is the primary somatosensory strip. So there's one more feature that we have to remember about hemispheric functions, and this is a feature that was discovered, or it wasn't. Well, its discovery is attributed to Jean-Paul Broca, who was a great French neurologist. There were some rumblings about this prior to his pronouncement, but what he told the world was that the left hemisphere, the left cerebral hemisphere, does something that the right cerebral hemisphere does not do. In all of these things, we're talking about match function between the left and the right. But what Broca discovered is that the left hemisphere is what he called dominant. It deals with language. And so injury to various parts of the left cerebral hemisphere will result in something called aphasia, which is an inability or an impairment of language, either understanding language or expressing language. And there are two different types of aphasia, two general types of aphasia: the receptive, understanding language, and the expressive, producing language. And Broca named the two patients that he used to name this finding were Le Borgne, who could only say tan, 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 and Lalonde, who could say these words: oui, no, toi, toujours, and Lelo, which was a version of his own name. And as it turns out, the brains of Le Borgne and Lalonde are both present in Musée Dupuytren in Paris. You can't take pictures at that museum, but you can go there and you can see the original brains of these patients. So the implication is that an individual with a language problem is going to be paralyzed on the left or the right, unable to make voluntary movements on the left or the right. Well, the answer is the right, because the left hemisphere is what's been is controlling language. Okay, so just to give you an example of what aphasia looks like, this comes from my aunt, and this was written well after she was on her way to recovery. She says, "I'm okay, right? Except symbol can't come out mouth in speech." And another part, she says, "I draw flag out hopistol window, would wave if I could," spelled COOD. Skill still in hand. So there are a lot of spelling errors that she's done to convey the confusion that an individual with aphasia experiences. And these people with aphasia are very seriously affected. It's very devastating. The great news is that, as we'll see in the next module when we talk about strokes, is that people recover from them. So I just went to visit my aunt very recently, and I can't tell that she ever had a stroke. So she has absolutely none of this aphasia that's noticeable to me, at least. And here's another instance of Jill Bolte Taylor, who wrote a book about her experience of having a massive stroke, and she also has recovered. So this is just telling you that while these are very devastating effects that you can find in the cerebral hemispheres, they often do get much, much better. And we'll come back to that towards the end. So now what we're going to do is we're going to move on to looking more directly at how the brain is supported to live, how it gets its oxygen and its blood flow, and what can go wrong, primarily what can go wrong with strokes.